Picture this. You're sitting in the exam hall. The invigilator announces you have 1 hour and 15 minutes. You flip open your Cambridge IGCSE Physics 0625 past paper, and immediately your heart sinks. Staring back at you is a 6-mark extended response question on force, mass, and acceleration. The clock is ticking down, the tension is building, and you have to perform. Now, I want to introduce you to two very different students facing this exact scenario. Let's call them Alex and Sam. Now, Alex is a classic overloader. Alex has memorized every single formula in the entire physics textbook. F equals ma, W equals mg, P equals mv. But when the question asks to explain the effect of mass on the acceleration of a rocket, Alex just dumps raw facts onto the page with absolutely zero analysis, no link back to the question. On the other hand, we have Sam. Sam is a rusher. Sam completely misses the specific command word requirements, ignores the instruction to use cause and effect, and just writes, "It goes faster because the engine is on." Both of these students are losing massive amounts of marks, and it has nothing to do with their baseline intelligence. It has everything to do with strategy. Welcome to this explainer on Cambridge exam strategy, where we act as your navigator. Think of us as the astronomer, helping you navigate by the stars, and in this case, those stars are your key command words. We are going to chart your course to top marks. We aren't just going to memorize equations today. We are shifting entirely from rote memorization to a deep, cause and effect understanding that examiners absolutely love.
Here's the agenda for today's session. 1. The concept-first approach. 2. The 4-step framework. 3. Cause and effect physics. 4. Overcoming exam traps. And 5. The quick recall system.
Section 1. The concept-first approach. Start with purpose.
A truly strong study session shouldn't ever start with a barrage of abstract formulas. It needs to start with purpose. Ask yourself right now, what physical effect, measurement, or prediction actually depends on understanding force, mass, and acceleration? Making the idea feel necessary makes you far less dependent on memorized wording. Let's go back to our student Alex. Alex memorized Newton's second law as just F equals ma. But what does that actually mean when rubber meets the road? If you know exactly why we need to calculate force to stop a moving car, or why mass matters when launching a rocket into orbit, you can reason your way through the absolute trickiest exam questions Cambridge can throw at you. Imagine a rocket burning fuel. As it burns fuel, its mass is actively decreasing. If the thrust, the force, remains constant, but the mass is dropping, what happens to the acceleration? It increases, right? That is cause and effect. It's not just a formula, it's a physical reality. When you visualize the rocket getting lighter and therefore accelerating faster and faster, the formula A equals F over m suddenly makes complete logical sense. You don't have to desperately try to remember the triangle in the exam hall because you intuitively know how the universe works. You know the concept first. Now, before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so shifting from rote memory to conceptual anchors is your first huge step. If you just remember the rocket, you're already beating the rote memorizers.
Section 2. The 4-step framework. A micro-gateway.
This topic of force, mass, and acceleration acts as a micro-gateway into a much bigger scientific pattern that applies across your entire IGCSE physics syllabus. We can break down any high-mark answer into 4 clearly linked steps. Listen closely, because this is how top students consistently structure their physics answers to hit every single assessment objective. Step 1. Identify the quantity or phenomenon. Are we talking about resultant force? Are we talking about inertia? Step 2. State the relationship. This is where your formulas come in. Force is directly proportional to acceleration when mass is constant. Step 3. Explain the underlying physics. Why does this happen? What is happening at the level of particles, or in terms of opposing forces like friction and air resistance? And step 4. Connect it to an observation or a real device. Now let's look at our rusher, Sam. Sam skipped steps 2, 3, and 4 and just wrote an observation. That's a 1-mark answer on a 4-mark question. The absolute best exam answers don't just spit back a formula. They combine conceptual understanding with practical application. When an examiner sees an answer that walks logically through these 4 steps, they see a student who has genuinely mastered the subject, not just someone who crammed the night before. You're building a logical argument, almost like a lawyer proving a case, but your evidence is the laws of physics.
Section 3. Cause and effect physics. No isolated facts.
To truly master this, we must insist on cause and effect reasoning rather than just reciting isolated facts. The examiners write in their reports year after year that students lose marks for using vague, everyday language instead of precise physics vocabulary. But here's the secret. A great explanation actually moves gradually from everyday language to that precise vocabulary. Understanding has to begin with a concrete example that you could explain to anyone on the street. Let's say you're pushing a heavy shopping cart versus an empty one. In everyday language, you'd say, the heavy cart is harder to get moving. That's your intuition. That's cause and effect. But you cannot write that in the 0625 exam. Only when you have that conceptual grasp should you introduce the strict physics terms. The heavy cart is harder to get moving transforms into an object with greater mass requires a larger resultant force to produce the same acceleration. Do you see the difference? You're taking your intuition and wrapping it in the language of a physicist. If you're dealing with a speed-time graph, don't just memorize the shape. Understand exactly what the slope means. Physically, it's the acceleration. Understand what the area under the line means. It's the distance traveled. When you link the visual shape on the paper to a real car speeding up or slowing down, you make your knowledge bulletproof. You're translating reality into mathematics, and that is exactly what the Cambridge command words are asking you to do.
Because ultimately, this micro-topic lives entirely outside the classroom. Ideas from force, mass, and acceleration appear literally everywhere. They are the foundation of engineering, vehicle safety, transport, energy systems, communications, medical technology, and even astronomy. To truly lock this in, you must be able to name at least one real situation where these concepts help us predict outcomes. It matters because understanding F equals ma is what keeps bridges from collapsing under heavy loads. It's the exact physics used to design crumple zones that make cars safer to crash in, increasing the time of impact to reduce the deceleration and therefore the deadly force on the passengers. It's how we calculate the exact thrust needed to get communication satellites into orbit. If you can attach the physics to the real world, your brain tags the information as important for survival, rather than useless exam trivia, which dramatically improves your recall. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's keep building that mark potential.
Section 4. Overcoming exam traps. Secure your marks.
Now that we understand the core concepts, let's pivot to specific exam strategy and look at the solution to the most common exam traps. We are going to use something called the DREA method, D-R-E-A. This is heavily aligned with the Peel framework, point, evidence, explanation, link, that top students use across all subjects, but DREA is perfectly tailored for the specific demands of the Cambridge physics syllabus. It stands for definition, relationship, explanation, and application. This is the safest, most reliable method for structuring your extended exam answers. Let's do a little interactive workshop right now. I'm going to give you a scenario. You have a data table showing the stopping distances of a car at different speeds, and the question asks you to explain how doubling the speed affects the braking force required to stop in the same distance. Now scan that conceptually. What is the core trend? It's not a linear relationship, is it? Okay, let's use the DREA framework. Definition. Define the core terms. Braking force is the resultant force causing deceleration. Relationship. State the physical relationship. A higher speed requires a greater deceleration to stop in the same distance. Explanation. This is the underlying physics. Kinetic energy is proportional to velocity squared, so doubling the speed quadruples the kinetic energy, requiring 4 times the work done by the brakes. Application. Connected to the real device. Therefore, the braking system must apply 4 times the friction force to the wheels. Boom. That is a completely flawless, full-mark answer. It acts as an ultimate blueprint. Hit all 4 of these points in a structured question, and you are building an incredibly secure mark-winning response that leaves absolutely no room for the examiner to dock points.
Let's compare a weak response to a winning one and see this transformation in action. We are going to look at our 2 students, Alex and Sam, and rewrite their answers live. A common weakness, like we saw with Alex, is writing down the correct formula but failing to explain the variables in the context of the specific question. Or like Sam, quoting a physical process without linking it to a physical effect. That is exactly where marks vanish. So the question was, explain the effect of decreasing mass on the acceleration of a rocket, assuming constant thrust. Alex's original answer was just F equals ma, red pen. 1 mark for the formula, but nothing else. Sam wrote, it goes faster, red pen, 0 marks. Now let's apply our strategy.
Let's turn those red marks into green check marks using the DREA structure, which is our physics success blueprint. We define the terms. Thrust is the constant resultant force, mass is decreasing. We state the relationship. According to Newton's second law, acceleration is inversely proportional to mass when force is constant. We explain the physics. Because the force is undivided by a smaller mass value, the rate of change of velocity increases. By ensuring every single microtopic is tightly connected to reasoning and application, you completely counter those common errors. You don't leave the examiner guessing what you know. You prove your complete mastery of the subject. You've decoded the command word explain, and you've provided the exact evidence required.
Section 5. The Quick Recall System. Deploy your knowledge.
We've learned the concepts, we've broken down the exam structure, and we've decoded the command words. Now we need to make sure this knowledge is completely locked in and ready to be deployed in the exam hall under intense time pressure. I want to present you with the complete physics answering system. There are 3 rules that absolutely guarantee top marks. Rule 1, command word decoding. Rule 2, framework application, like Dreyer or Peel. And Rule 3, the time management matrix. To master Rule 3, you need a self-testing system with these 4 quick recall prompts. 1, what is the core idea? 2, what changes physically? 3, what quantity or graph shows it? And 4, where is it used? If you are staring at a blank page, run through these 4 questions in your head. Let's take terminal velocity as an example. Core idea, air resistance balances weight. What changes physically? Acceleration drops to 0, speed becomes constant. What graph shows it? A speed-time graph leveling off to a horizontal line. Where is it used? A skydiver falling through the air. The rule of thumb is incredibly simple. If you can read these 4 prompts and answer them aloud clearly and confidently for any topic on the syllabus, that topic is secure, and your time management will be flawless because you won't be stuck hesitating. You are 100% ready for the paper.
So we're going to end on a provocative thought to test your readiness right here, right now. I want you to ask yourself, can you define the core idea of force, mass, and acceleration and chain it to a real-life cause and effect right now? Don't just nod along at the screen. Actually try to do it. Test your new conceptual understanding immediately. Think of the concrete example, whether it's the rocket, the shopping cart, or the car brakes. Use everyday language first to make sure you understand it intuitively, and then apply the precise Cambridge physics vocabulary to lock in the marks. Mastering that specific chain of reasoning is how you truly master the subject and beat the exam. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Keep focusing on those fundamental concepts, keep practicing your frameworks, and I'll catch you on the next one.